Hello once again and welcome. My name is Kent Trammell and this is the 11th and final video in this series of tutorials covering the creation of a realistic portrait in Blender. At this point we've got all of our elements created and ready to be framed, rendered, and composited into a final image. This video is going to be a little different in that I'll be talking and explaining much more than I'm doing. So this is the final image. I mentioned in the last video that he was starting to kind of feel like a professor to me. And with that goofy expression, let's just say that he's the cool, funny teacher who teaches calculus or something crazy. So I threw in a simple classroom background with a chalkboard and kind of framed it as if it were shot in a movie with the camera a little bit low. So overall, I guess I'm pretty happy with this result. Since I'll be focusing on render setup and post-processing, let's talk about that conceptually for a minute. But first let me preface with the fact that I do not consider myself a proficient compositor. I enjoy finalizing my images, but it's one of the least polished of my 3D skill sets. If you are proficient in compositing, I can almost guarantee that you'll disagree with some of my methods, but this is simply how I approach it. I don't know how common this misunderstanding is for new users like it was for me, but when I first started 3D, I assumed that my final image always just came straight out of the render engine. At first I didn't even know about post-processing, and when I found out about it, I hated the concept. I mean, after spending all this time setting up shaders and lights, tweaking render settings, and waiting for the render to finish, you're telling me that there's more work to do? So yeah, it took me a while to understand and adopt post-processing into my workflow, but the benefits are definitely worth it both in render time savings and creative flexibility. When rendering 3D imagery, render passes and render layers are standard features for breaking down a rendered image into its separate elements. As far as I understand it, passes are used to break down a single render into its individual components. For example, an image's diffuse component, specular, shadow, reflection component, etc. But note that these are all extracted from the same render. A render layer is different in that its purpose is to separate and organize pieces of the scene, like a floor from a box that's sitting on the floor, for example. So let's take a look at this image from the Blender wiki. It's common for both features to be used in conjunction. Here we have two render layers that have been set up. The first is called floor, and it contains the floor geometry. Notice that it also has two passes associated with it, the diffuse pass and the shadow pass. The second layer is called object. It contains the cube geometry and three passes, the combined image pass, z-buffer pass, and motion vector pass, called speed in the node tree. This is how both passes and layers can be used together. And that is my best attempt to explain passes and layers in their traditional usage. Now for me in my workflow, I come from a background in Maya and 3ds Max, which allowed me to render passes and layers in a certain way, sort of a hybrid method that I think offers even more flexibility. If you've watched part 5 of this series, you've already seen that I like to use different materials for different components of the render. In that video, I used a Blender internal material for the subsurface scatter and diffuse components, and a cycles material for the specular or reflection component. I did this for a couple of reasons. One, after doing this for years, it makes more sense in my head, especially with something as complex as human skin, to finesse each component separately instead of the same shader. And two, Cycles just renders reflections much faster than Blender internal. So when I use Blender's pass and layer system, the biggest lack of control I find is the ability to assign different materials as well as different render settings in each render layer. Let me show you what I mean. So if I go over to my render settings and reveal my layers options, we have visible layers, which are also controlled over here in the 3D view. Then we have layers that are included in the render layer. By default, they're all on, so any visible layers in the viewport will be rendered. Below that, we have our mask layers. To the left, we have a light override, which if a light group is selected, all the lights will be overridden by what's in that light group. And then we have a material override. But this material override is for one material to override all the object's materials that are rendered in this layer. Typically, I like to just have more control over my materials and what's being overridden. I also like to override certain render settings, or I would like to be able to do that. So ideally, I would create a new render layer, and in this example, let's say that I have my head rendered at 100% my final image resolution, but my hair I want on another render layer, and I want that to render twice as big as the final resolution. And I've said in previous tutorials I like to render hair twice as big because it solves the anti-aliasing issues especially when I scale it down to match the final resolution. Ideally, I would be able to change this to 200%, but still having my head rendered at 100%. But when I change back to the first render layer, we see that it stays at 200. And so these render settings carry over through all the render layers, and there's no way to override them. And this is where I start to feel a bit limited in Blender compared to what I'm used to with Maya and Max. Both of those packages, either through the default system or a plugin, allow the user to override any and all settings and materials for each layer. And this gives the user complete control. So being as stubborn as I am, I still want this level of control in Blender, and fortunately this is possible with scenes. Scenes can store all of Blender's settings, materials, objects, everything separately, but they can also share data. So by thinking of my scenes as render layers, I can share, let's say, my head mesh between all scenes, which is important because if I make a tweak to the mesh, that tweak will propagate to each scene sharing that same mesh. And this also means I can assign specific materials and set specific settings for each scene. So let's see how that's working over here. We've got background beauty, depth, hair facial, hair scalp, head beauty, head ID, and head spec. All of these are my scenes that I'm using as render layers. And each of these is created by going to the header, clicking this plus button, and clicking link object data. So if I do that real quick, we see we have head beauty 01. Now let me open this and let's see, click on my head. We can see that this is called head 004. But if I go up to the original head beauty and click on my head there, this is just called head. But if I click on that and click on the head object data tab, we can see this is head 005 as the object data. And also down here, where is it? With head 04 in the other scene, we're still sharing head 005. So this is kind of a key for this to work. Again, I want my changes to propagate if I have to make changes to the mesh. And this goes for all my meshes, my clothes and the background. So another important thing to remember is with my materials. So right now I've got the head beauty 01. Let me just go ahead and remove that. And here in my head beauty scene, if I go to my materials, we have my tri-layer material, epidermal, blah, 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 all the way down. And then if I go to my depth scene, it's the same geometry, but whoops, on my head object, we've only got one material set up, and it's called depth. But they're still sharing the object data. And the key to making this work is right here. And that's what the material is linked to, whether it's the object or the object data. By default, Blender assigns each material to the object data. And this is bad for this particular setup because I'm sharing object data. So in each scene, if I change the material, it's going to change for each scene. So what that means is that each object needs to have its materials assigned to the object and not the object data. You can change this by default if you open up Blender Preferences, and in the Editing tab, we have this Link Materials To, and we can change that to Object instead of OB Data. And yes, so that's necessary. All of our materials need to be hooked up to the object instead of the object data. This is what will allow us to assign specific materials for each scene to the same geometry. So now that we know how each of the scenes are set up, let me start going through them one by one. This first scene we have is BG Beauty, or Background Beauty, and this is a cycles scene, and it's only rendering this background, which is our chalkboard and our wall. I have the portrait or the head geometry and the clothes geometry visible, but if I click on their objects and go to their the object panel, in ray visibility, I have camera turned off. So if I just turn on rendered here, we can see that we have a shadow happening from our head, but the head itself is not being rendered. This background is very simple. We just have some painted cinder block kind of material for the wall, and a wood texture that is one of my kitchen stools. And the chalkboard texture. All of these textures are either procedural or painted by me, or also from photos that I took, except for the chalkboard. I didn't have a chalkboard laying around, so I can't redistribute this image, but just go to Google and find a simple chalkboard texture. And I'm not going to go over the shaders for these background elements. It's not the purpose of this tutorial. The scene file is available to citizens, and all the materials will be included there. So let me go on to the depth scene. This is a very simple scene. All the objects are being rendered, and they are being rendered with the same shader that I have named depth. There's nothing super special about this shader, except that I've turned it to shadeless over here in the render material settings, right here, shadeless. And I think that speeds up render time a little bit. Let's see, all my lights are turned off. And if I go to my render settings, I want to have this Z checked on in the layers options. This will create the Z buffer data in the render. If I open up the scene and scroll down to the head and the modifiers open, we can see that I'm rendering all of my hair systems. And this is important to get the depth information for again, all the objects in the scene, including my hair. If I go to the Particles tab, I want to make sure that Strand Render is turned on for the scalp, and the children are set to 100. The renderable children are set to 100. And lastly, I want to set up my camera. So if I select the camera, go to its data, I want to check on limits. So if I turn on my limits, it's chugging a little bit because all this hair is showing. But we can see that the distance slider, that's what I want to be in focus when I use the defocus node in the compositor. So it's very important to have this set up before you render. And then let me render this and show you what we get. We should have an all gray image, but then if we go over here to the Z buffer draw option and click that, we can see a white silhouette of our head, and then it gets grayer behind him. And this is good. This means that the Z depth is working and it's a successful pass. This information will be perfect for the for defocusing in post. Now let's go to the next scene, which is hair facial. In this scene, I want to isolate my facial hair. So I am rendering only my head. And as I go into wireframe, we can see that it is being rendered, but it has a shader called BI holdout. And this works the same way as the Cycles holdout shader. And it's a mask. And the other shaders that we have on here are our strand materials. And they are set up just like I did in the last tutorial. But I want to make sure that I have cast only disabled. Unfortunately, each individual material cannot have different settings throughout the different scenes. So this material, strand browse, in each scene has the same settings, and they will be propagated anytime that I change them. And that's not ideal, but it's just the way things work here. But I've written a few lines of code that will make changing this setting as easy as one click. And so basically it looks for each material in the scene, and if it has strand in the name, then it will toggle the cast shadows only option. So if I click that, we can see that it disappears, and also all of the little spheres off to the left, the sphere icons, come back. If I click it again, we can see that they disappear. So I want cast only shadows disabled, so when I click that button, we can see that they all come back. So now let me run through the lighting I have set up in this scene. As I orbit and zoom out a little bit, let's see, we can see these cards that I have set up at the top, and these are meant to represent the fluorescent bulbs that would be attached to the ceiling, shining down. At least that's the way my classrooms were set up in school. That's what I remember. But anyway, we've got some more of the same cards with the same material over here, and these are meant to represent the lights from the window. And they, again, are not emitting light. Neither are these up here because we're using Blender Render. But they will be showing up in the reflections of the eyes, and that's really what I want them to do. Okay, as far as actual lights, we've got two over here that are representing sunlight from the window, and this one here is more or less the key light. It's the most powerful and aimed directly at his head, at our character's head. And then this other light is a duplicate of that same light, but it's not as powerful. Let's see, we've got a light off towards the back side of his head, and this is meant to represent some bounce light coming from the window lighting, bouncing off the wall and chalkboard and then hitting him inside of the face. And we've also got another light over here, and that's more of a fill light, but it's the explanation for it is that remember, we've got a chalkboard back here, and over here I'm imagining a door with with a window and some blue light coming from that door from the hallway. And so that's my justification for that light, but also it's stylistically pleasing. And finally, we've got a couple more cards here, and these are just artistically placed to show up in the eyeball reflections. There's no other reason besides that. Okay, so that's my lighting for the scene. Now let me do a render. Now if we look at the alpha of this render, we can see that our head is occluding any hair that is behind the head. So that's the purpose of that holdout shader. Also, another setting, if I click on the far left checkerboard icon, we can see our image pre-multiplied over the background. Now this looks kind of weird. It looks like our hairs got much thicker, and the reason for that is I'm rendering a straight alpha, meaning it's not pre-multiplying the background into the RGB values of the render. So if we go to the render settings and scroll down to shading, the shading tab, there's an alpha option that I have selected as straight alpha. And what this means is that the transparent, let me read the description, the transparent RGB and alpha pixels are unmodified. By default, Blender has sky selected, and what that means is in the world tab, whatever this horizon color is, your alpha will be pre-multiplied over that color. Now the problem with this reveals itself when I start stacking my render layers and passes back on top of each other in the compositing stage. Because when you start to stack them, you'll notice a black outline, a very faint black outline around your elements. And this will ruin a good composite. And the reason for this, if I zoom in here, rendering a straight alpha extends the pixels beyond the alpha's reach. So if I switch between, this is my alpha and this is my straight RGB channel, you can see how skinny the alpha is up here compared to here. And what a pre-multiplied image is doing is your alpha is not black and white, it's actually grayscale. So it knows what to do with black, that means it's perfectly see-through. White, it's not see-through at all. But then with your gray values, anything between 1 and 0, what color is supposed to be used? So in a pre-multiplied image, when the alpha is 1 over here, even these values in this alpha, none of them are actually white. We have a couple white values over here, but these are mainly gray. So what the pre-multiplication has to do is, let's just say this is a 0.5 gray value. So 0.5 of that value has to be brown, and then the other half of that value is a question mark because it's alpha, it's see-through. And the pre-multiplication will just add the other half of the value in black. And that's when you composite that, you'll start to see that black come through. And I want to avoid those black outlines, and it is black because, again, it's the horizon color black. If this were white, it would be a white outline, or green, it would be a green outline. But in this case, it's black by default, so it's a black outline, and I want to avoid that. So the alpha, changing the alpha to straight alpha down here will fix that for me. And that's going to be my rule of thumb for any of these passes or scenes that I need an alpha in the final render. Anyway, this is what I want from the render, so this scene is working well. And I'm going to go on to my next one, which works very similarly, and that's the hair scalp layer. Again, with this scene, I'm rendering my head with the holdout shader and just my scalp hair, none of the facial hair. And if I go to my particle settings, we can see that it's a scalp, and I need to make sure that I have strand render on, and also my render hair is up to 100. I have to, anytime I'm rendering my scalp or any hair in general, I need to check these settings because unlike my objects, which can have different materials per scene, the particles do not do the same thing. So when I change a setting for the particles, it propagates to each of the scenes because it's using the same particle system. It's not the traditional Blender method for separating your render into its individual components, and I wouldn't even call it the best method necessarily, but it's, again, just the way that I like to do things. Let's take a look at the lights, and they are lights specific to this scene, and they're set up with buffered shadows. Same settings from the last tutorial, so I'm not going to go over those again, but this is the light that's coming from the window, sort of the key light. We have another light back here, which is representing the bounce light off of the wall and chalkboard. Another light, which is only there for stylistic reasons, and it's to add a little bit more of that hair rim lighting effect. Not too much, but a little bit in there. And this last light is representative of that door with a window, and we have some hall light coming through, sort of a fill light. So that's what's set up here. So let me do a render. Yeah, this is the way I want my hair isolated. Okay, so let's go on to the next scene, which is head beauty. This scene is similar to the way it was in all the other videos. We've got our head and our clothes rendering together. This is called the head beauty. So each of these objects have their respective shaders and textures assigned to them properly. And for example, we have our tri-layer material to the head, which I want to receive shadows from the hair. We've already rendered our hair elements separately, but we have not had the shadows render onto the head mesh, and that's where we're going to do that in this scene. So if I click on my strand beard material, we can see that cast only is not enabled. If I run this script again, it turns it on for all of the strand materials. And I need to go to my particles tab, and with my scalp selected, I need to turn off strand render and turn my render strands down to 20. This way the shadows will render as ray trace shadows instead of depth map shadows, or buffered shadows, I mean. So let's take a look at this light setup. It's a bit simpler than, let's say, the facial scene, but we've got the same light cards that will show up in the eye reflections. We've got the lights from the windows, also those cards that will show up in the eyes. We don't have the extra lights that were bouncing off of the wall that I said, because I wanted those more for the hair. I don't need them in this scene, so they are not being rendered, but I do have a fill light that's coming from the invisible hallway. So I will render this now. Okay, everything is good with this, except I think I forgot my hair. Yeah, over here in the outliner, you can see that all of my hair systems are not renderable. So this actually brings up a good chance to show you this other script. And what it does is loops through the modifiers attached to our head mesh. And if it's a particle system, it will toggle on or off for renderable. So if I just click run script, we can see that they all pop on over here. And so let me render that again with a hair on. Okay, that's a little bit better. We can see if I jump back and forth between them, this is without hair shadows, this is with the hair shadows on. We can see that there's actually a substantial difference from the shadows. Okay, so I definitely want shadows on in this scene, and with that tweaked, we can move on to, I'm going to go ahead and move on to the head spec scene. In this scene, we're rendering the head with the same spec shader that I detailed in part 5. Nothing's changed since then. We're also rendering the clothes and the eyes with a holdout shader, no background. The biggest change has taken place in the light setup, or the light planes, and they've just been moved around to match this new composition's lighting. So we've got our overhead lights We've got our window lights and bounce lighting from the wall, this light from the invisible door, and then this light is a little bit different. It's serving as a bounce light from the floor. So that's really all there is to this scene. I'll go ahead and render it. Yeah, this is what I'm looking for. We've got some strong light coming from the left side of the frame where the window is, and then we've got some faint light coming from the right side of the frame where the door is, and also the ground plane, not the ground plane, but the plane on the ground that's serving to bounce light up, so to speak, is showing up here at the bottom of the nose, the bottom side of the nose. And yeah, this is looking good to me. This scene is done. And the last scene I have is the head ID. I created this scene the same way I used to when I used Maya and Max. And the purpose of this scene is to generate masks that can be used in compositing to be used as factors in editing nodes. So if you remember in my head beauty pass, I rendered my head shader, my clothing shader, eyeball shaders all together in the same pass. Whereas some compositors would prefer to separate every single aspect of this image, the buttons, the shirt, the tie, all in their own layers. I like the way that they render together and didn't want to take the time to set up those individual scenes. But when I'm compositing, let's say I want to make the shirt a little bit brighter or the jacket a little bit darker, with the masks that I can generate from this ID pass, it will make those changes very simple in compositing. Now, I'm aware that this is a different method for creating these masks. Blender has a more built-in method over here in the render settings, in passes, object index, and material index. I'm just choosing to do it a different way. This is the way that I've always done it, by using colors. And so these materials that I have set up are simply shadeless materials, and each of these colors is the pure red, green, blue, cyan, yellow, and magenta values that are easily separated with compositing nodes. So there are also no lights that are rendered in the scene. It needs to be very quick, just a very quick render. Okay, so let's see what we have. Alright, this will work perfectly. I've got the red shadeless material assigned to the head for any skin levels or coloration that I want to change separately from the other elements. Blue for the eyes, cyan for the tie, green for the shirt, magenta for the buttons, and yellow for the jacket. So that is it for my scenes. One last note before I go on to compositing these passes or render layers, whatever you want to call them, together, is for the explanation of these layers, I've been rendering the dimensions 50% of my final output. In order to achieve the highest quality render, I actually bump this from 50% to 200%, not only on my hair scenes or passes, but also on all of them. And in the compositing, I will shrink them all down to 1920 by 1020, which I thought was 1080. Oh well. I like shrinking them down to give a crispness to the image. Anyway, I'll get to that in the compositing. I also am in the habit of saving each render externally in an image file. I know that Blender is capable of storing each render in the render layer node in the compositor, but when some of these scenes take a while to render, like the head beauty can take between 30 and 50 minutes to render sometimes, if Blender crashes, I have to re-render each scene again. So by saving each render externally, I can avoid that frustration. And it also serves as a way of tracking my progress or giving me the option to go back to a previous render. So that's what I've done. I have saved all these images externally, and now I'm ready to jump into the compositor. But first I want to switch to my head beauty scene because I know that this is where I've stored my compositing nodes. So I'm going to maximize this node editor window and switch to compositing nodes. So this is my node tree. I've tried to organize it based on each individual render layer, and I will just start up here at the beginning with the head beauty section. With this image node right here, I'm going to hit Shift Control left click, which is a hotkey that will plug in this node directly into my viewer, which is the source for my backdrop. So let me turn that on right now. And we can see here that this is my raw head beauty pass. And what I want to do first is lighten up the skin a bit. The skin with the eyes, but I want to leave the clothes as they are. So I'm going to do this with an RGB curves node, but I need to mask out just the head and eyes portion of the image. So I'm going to do that with my ID mask. So let me click on that and plug it into the viewer. We can see here that in order to separate my head and my eyes, I need to grab the pure blue channel and the pure red channel. And this can be perhaps a little bit tricky, but let me go ahead and cut these connections and start from scratch. So if I have added a separate RGB node over in converter separate RGBA, and if I plug this up into the viewer, we can see that I'm not only getting my head up here, but I'm also getting my jacket and my buttons. And the reason for this is, clicking on my color again, we can see that yellow not only contains green, but it also contains red. It's a combination of red and green. Magenta is a combination of red and blue. So when I separate my RGB channels out, red is contained in the jacket and the buttons. So what I need to do is separate the red out from the yellow and the magenta. So I'm going to write a little formula to help explain this, what I'm going for. I'm going to create a new grease pencil layer, change the color to white. Alright, my formula is we have red in our head, red and green in our jacket to make yellow, red and blue in our buttons to make magenta. So what I need to do is subtract the green and the blue. By subtracting green and blue, it will actually cancel out the yellow and the magenta, leaving me with pure red. So let's set that up. I'm going to delete that grease pencil layer. And up here I have a mix node that is set up with a subtraction operator. And the factor is set at 1. And I've got a duplicate of that mix node right beside it. So over here at our separate RGB node, I'm going to plug that up and drag the red channel into the first socket of our mix node up here. And so I want to subtract from the red the green channel. Let me drag the green channel into socket 2 and now plug that into the viewer and see what happens. So we see that our jacket disappears. That's awesome. Now we just need to subtract the blue. So I'm going to drag the output from this first mix node into socket 1 of the second subtract mix node. And then into socket 2, let's drag our blue channel. And then click that and see what happens. Yeah, we lose our buttons. So this is perfect. Now I just need to do the same thing for the eyes and isolate those eyes, and then we'll combine both isolations. So let me go to my color, plug that up, and let's see, I want blue. I want pure blue to be isolated for the eyes. So the same way that I did above for red. So let me plug up the separate RGB into the viewer and click it 2 more times to see just the blue channel. And we can see that we have the tie, the buttons, and the eyes. So we need to get rid of the tie and the buttons. So when I plug in the blue channel to socket 1 of this mix node with a subtraction operator, and then grab the red channel and plug it into socket 2, we should see our buttons disappear. And they do. So now we just need to plug in the green channel into socket 2 of the second mix node to get rid of the tie. There we go. In order to combine these, I've added another mix node, changed the operator to lighten, and I can get rid of these little nodes here. And I can just drag our head isolation into socket 1 and our eye isolation into socket 2 and plug that up. And we can see we have a combination of our head and our eyes together. And this will be used as a factor in our RGB curves node over here. So if I plug that up and then turn it on and off, let me position this a little better. Turn it on and off, you can see that only the head and eyes are being lightened. And that's as much as I'm going to tweak the head beauty pass right now. So I will move on to the specular component, which is simply the image node down here plugged into a hue, saturation, and value node with the saturation turned down to 0.2. And this is plugged into the second socket of a mix node with an addition operation. And the factor for this mix is only 0.2, so it's quite faint actually. And let me position this right. So let's see what that looks like with the spec added. You can see the difference as I click back and forth between them. I don't want them to look too sweaty, so that's why the factor is so low. But I like this level. It's a nice specular sheen that looks realistic in my opinion. After that, we're going to add the background component. And this is not a mix node, it's actually an alpha over, with the background plugged into socket 1 and our head beauty and spec plugged into socket 2. Let's see what that looks like. And I want to make sure to turn on convert pre-multiply. As I was talking before, when I render with a pre-multiplied image, turning this on will cause my straight alpha to pre-multiply over the background image. So this is what I want. Instead of in the render, it would be pre-multiplying over black. Here it's accurately pre-multiplying over the actual background. After this, we have the hair facial that I want to plug up. So it's just the image plugged into an RGB curves node, but I have that muted, so I can tweak some curves if I want, but I've muted it for now. And when we see what's happening there, I also want to check on convert pre-multiply here. And yeah, that looks good to me. Next we have the hair scalp, which is the same as the hair facial. No actual color editing happening here. I'm keeping this pretty simple. So let me plug that into the viewer. Also with the convert pre-multiply turned on. And that's all of my elements combined together. So now I'm ready to get into some post-processing techniques. The first of which is a defocus effect. So here we can see I've got an image node with my EXR image file that's capable of containing the Z depth information. So I'm grabbing the Z socket and plugging it into the Z socket of this defocus node, which can be found Shift A filter defocus. Let's just compare the settings that I've changed. I've changed the bokeh type to octagonal, keeping the angle at 0, and I'm turning on use Z buffer, which brings back this f-stop value, which I've changed to 3. This f-stop attribute is what controls how much defocusing is happening in your image. So 3 is quite low. As you can see in the default defocus node, the f-stop is set to 128, which is very high and very blurry. And max blur, keeping it at 16, and my threshold I'm turning off, which is 0, and turning off the preview. So now if I plug this into the viewer and get rid of this other defocus node, let me zoom out. I want my defocus to be noticeable, but I also want to be very cautious of going crazy with it, because if it's too much, it'll start to feel miniature and ruin a realistic scale. So as I turn this on and off, hopefully you can see the change, especially look over here at the wall and the chalkboard. We can see that they blur the most. We can also see a little bit over here on the side of his face and the hair. We can see that blurring a bit, but it's still enough in focus to be believable. So as a reminder, it's important to set up your camera limits when you render this pass, or else this defocus node will not work. So that's it for the depth of field effect. It's really pretty simple if everything's set up correctly when you render. And now I'll move on to the chromatic aberration portion, which I understand is quite controversial. It's sort of a polarizing effect. I tend to think people either love it or hate it, use it in everything or never use it. The fact is, chromatic aberration exists in a camera lens, so if I'm mimicking a camera shot, I need to have it in there. But I do keep it pretty subtle, at least in my opinion. I've seen a lot worse. I'm sure some people say that it's way too much what I'm setting up here, but I'll go ahead and show you how I accomplish it. Blender has a wonderful little node called lens distortion, and this is sort of like the chromatic aberration node in Blender. And I would consider it a good node to use, and that's why I am using it here in this composition. But with Blender images, it's typically obvious when this has been used. It's very easy to overblow it and stray away from realism. So I do have it in my node tree, but it's very, very small. It's 0.01. But before I get there, I want to sort of globally offset my red, green, and blue values from my image. By doing this, I achieve a more stylistically appealing chromatic aberration, and when I combine both methods together, I get an effect that I like and keep it very subtle. So here I've added a separate RGB node, and I've taken the red socket and plugged it into a translate node, which can be found in Shift-A, Distort Translate. And for X and Y, I've plugged in 1, which I think are pixel values. So I've just merely moved the red channel up and to the right by 1 pixel. Then I'm taking the green channel and plugging that into another translate node and moving them in the opposite direction, 1 pixel to the left and 1 pixel down. Then I'll recombine the images over here in a combine RGB node, and let's see what that's giving us. It's really very, very subtle, but where you can look for it is on the edge of his face here, a little bit in this nose area, and also down here in the tie. A little bit of green bleeding here. So I'll switch back and forth. And hopefully you can see that change. You should definitely see it if you get your hands on this scene file. But that's a very subtle nudging that I'm pretty happy with. I like the offset of the channels. And then with my lens distortion node, I've got my dispersion set to 0.01, which is very slight. And let me plug this up and see the combination of them. This is a more noticeable effect. The closer you get to the center of the image, the weaker the effect. And as you extend outward from the center, we start to see blurring and the shift in red, green, and blue channels. So I'll switch back and forth a couple times. Again, the effect is most noticeable towards the outer edges of your image. But that's it for my chromatic aberration. I'm happy with this. It's subtle enough, but noticeable as well. And I will move on to the last section, which is a bit of coloration. First, we have a noise texture here, which if I minimize the node editor and on my world, I have created a texture called comp noise, and this will serve as sort of a film grain overlay. And it's not affecting the world, that's just where I'm storing it. It's a clouds texture, and it's color instead of grayscale. It's soft instead of hard, and the size is very, very small at 0.0005. And I have this plugged up into a mix node, the second socket of a mix node with an overlay operation. Oh, and I almost forgot. After the chromatic aberration is when I'm scaling my image down. So Shift-A, Distort, Scale will allow me to shrink this down half size. So over here in my view settings, you can see that my zoom is at 0.5. So what we're seeing in the backdrop is actually half the size of the actual renders. So if I change that to 1, we can see that it is an enormous set of renders. And some may think this is overkill, but I personally like to see a very crisp CG image, and this is the best way I can achieve it. Rendering it twice as big and scaling it down really yields some crisp results. So at this scale, let me plug that up into the viewer. And this will be the actual final output size. Okay, so back to the film grain overlay. Out of the scale node, I've got that plugged into socket 1 of this mix node, and let me plug that into the viewer. I doubt that you were able to see that difference, and it's even too subtle for me looking at it at full resolution, so I'm going to change it from 0.3 to 0.5, and that feels better to me. Film grain is a good way to add realism again to a composition, and I like what it's doing here, so I will move on to some more coloration techniques. The first of which is a vignette. This is a very common technique that basically serves to point the focus of the viewer where the artist wants them to look. So where my head is at, I've got white, and as it extends out, it gets darker towards the edges. When I have this set up as a multiply, we get an effect like this. I'll turn it on and off, but just around the corners mainly, you can start to see some darkening happening. As you can probably imagine, these enormous renders make for a very slow composition, so I am time-lapsing my switches. Okay, so that's the vignette. The next two coloration overlays are very similar. So with what little knowledge I have, I know that it's generally appealing, and it's definitely appealing to me, to have an obvious warm source and an obvious cool source in my images and in my compositions. So this first image that I've created, and these three images right here were all just created in Photoshop, very simple black and white gradients. This one is used as a mask for my warm coloration. You can see the mask gets lighter towards the left side of the frame, and this is where my window is, where my sunlight's coming in, and I want that to feel warm. So I'm plugging up this image into a mix node where I have 50% gray in slot 1, and then in slot 2 I have a color that's almost white but ever so slightly towards the orangish red side of the color wheel. And this mix node is plugged into another mix node, into slot 2 of that mix node. That's an overlay operation. So by picking the 50% gray over here in the first mix node, that color will have no effect in this overlay, but the bright orangey red color will definitely have an effect in the overlay. So let's take a look at that. I'll switch back and forth a couple times. Let me move it. You should be able to see how this left side of the frame is brightened by that bright orangey red color. And then I'm going to do a similar thing for the cool side, which will be the right side of this frame. So again, I have a mask that I've created that's a very simple gradient, brighter towards the right side and then darker towards the left. This I've plugged into an RGB curves node just to edit that a little bit to make it a bit brighter on the right side. And then this is plugged into the factor for this mix node. Same principle as the brightening mix node, but here I've got 50% gray in slot 1 and then a bluish color in slot 2. So it looks something like this. What this will do is add a blue overlay to the entire right side of the frame. I'm going to switch now with my coloration on and off, and I want you to take a look at the left and right side of the frames. We should see blue on this right side and then a warm brightening on the left side of the frame. And that's going to finish my composition. If any compositors are still watching at this point, you will certainly notice that this is a very simple compositing node tree, but I like to keep it simple and not go crazy in compositing. But all that's left for me to do now is render out the final image. So I will be sure to add a composite node, which is Shift A output composite, and plug in my overlay over there. Now minimize the node view, go to my render settings and change my resolution to 100. And in the post-processing tab, I want to check on compositing. Now when I hit render, Blender will be computing the compositing nodes instead of my scene. And this means we are done. All of the hours of work that have gone into this project simply serve to tell each of these 2 million pixels what color it should be. It's kind of funny to me to think of CG that way. But anywho, I am thrilled to conclude this series. I hope you've learned something from this video. Again, I'm not a skilled compositor and know that people can probably critique the mess out of my choices, but still I felt it necessary to include my workflow from truly start to finish. As a whole series, I hope you've been able to glean some useful information to be used in your own work. It's been long, but if you've made it this far, thanks so much for watching. Till next time.